Welcome back, class. Today we're going to be talking about finding surface area as well as what we call lateral area of prisms. So I wanted to start with reviewing our definition of prisms. A prism is a polyhedron that's formed by two parallel and congruent bases. Now this is going to be the key to our prisms, is identifying what is the base of all of these different surfaces. Now the lateral faces, so the surfaces that are not the bases in this prism, must be parallelograms. Keep in mind that parallelograms does include rectangles and squares. So often we might see the lateral faces as rectangles or squares. They could be parallelograms. So as we look at these two prisms here, first you want to identify the bases. Now the bases are going to be the two that are parallel to each other and always congruent to each other. So for example, I have this base that is a triangle, and then across from it, parallel to it, we have this second base that is also a triangle. This is what we would then refer to as a triangular prism. And in addition to those two bases, now you'll notice that there are two bases and the bases themselves are triangles. In addition to those two bases, there are also going to be, on this one, there are three faces. These three faces are the rectangles that are connecting those two bases. So there's one rectangle here, there is a second rectangle right here, and then there is a third rectangle down at the bottom, this third rectangle right here. So that's that third one. So there's going to be three either parallelograms or rectangles or squares. Now keep in mind the bases have to be congruent. So I'm going to emphasize that these bases must be congruent, but these rectangles or these faces do not have to be congruent. They can be, but they're not always. When we talk about finding surface area of prisms, there's two things that we generally look for. There's the lateral surface area, and then there's the total surface area. The lateral surface area specifically refers to the area of the lateral faces. Now, on the prisms up above, there were actually only three lateral faces. Remember, these were the three rectangular figures. So when we're finding the lateral surface area, what we need to do is find the area of, or actually, let me rewrite this. We're going to find the sum of the area of all faces. Okay, now the total surface area is basically the area of all surfaces. That's going to include both the bases plus the faces. So for example, in the figure above, we would have to find the sum of the area of all the faces, plus we would have to add in two bases. Remember that in a prism, there will always be two bases. I'm going to change that here. In a prism, there will always be two bases. Okay, now we're going to be talking about a couple of different ways of finding the lateral and the surface areas. One of the methods I like to use is just specifically finding the area of each of the surfaces individually and then adding up what we need to add up. There are also some formulas that we're going to look at that we're going to develop as we start looking at a couple of these. Okay, so let's take this first one. When you're starting with finding your surface area and lateral area, and you'll notice on this one that we want to find both lateral and surface area, so we do need to separate them, start by naming the prism. And when we name the prism, that means that we have to identify what the base is. And the reason we need to identify the base is because that's going to help us distinguish between lateral area or surface area. Remember, surface area is the only one that actually includes the bases. So if we go back to this figure, you want to notice that the two parallel and congruent surfaces are these triangles. So we have this one triangle here, and we have this second triangle here. That means that our two bases are going to be triangles. Now, start with how do you find the area of a triangle? To find the area of a triangle, we need to do 1/2 base times height. And if you look back at your triangle specifically, remember that base and height have to be perpendicular. So when we're looking at these triangles, what you want to look for is this height, which in this case is 13, and this base that it's perpendicular to. Now, since the base is not identified on this side of the figure, look across at this side and we'll see that this base is actually 14. So to find the area of the triangles, we'll do 1/2 times the base of 14 times the height of 13. And if we multiply that, that's going to give us an area of 91. Now, there are two triangles, so usually what I like to do is kind of make a list. For my first triangle, the area is 91. For my second triangle, the area is again 91. So this is going to be representing each of my triangles. Now, in addition to the triangles, now I have to find all of the faces. And there are actually going to be 3 faces in this one, and each of the faces is going to be a rectangle. So remember that to find the area of a rectangle, we're just going to do base times height. But you have to look closely at each face because they're not always going to be the same. So let's start with the surface down at the bottom. This one, we need to figure out what the base and the height are. And if we look carefully, we can see that the length here is 14, and this width here is 20. So our base and height of this first one is 14 times 20, which means the area of this first rectangle is going to be 280. Our next rectangle, I'm going to look at the one in the background. So now we've got this one and this one. And again, look closely, you'll notice that this is now 12, and this longer distance is still 20. So this rectangle is now 12 times 20, and 12 times 20 is 240. And then our final rectangle is going to be the rectangle that was in the front. So that is this one. And if we look at that rectangle, we can see that this length is 15, and once again, this longer length is still 20. So this rectangle is 15 times 20, giving me a third rectangle of 300. So now, as we separate, we go back and answer the 2 questions. Lateral area, remember, refers only to the faces, and in this case, there are 3 faces. So the lateral area is going to be adding together the 280, the 240, and the 300. These 3 surfaces make my lateral area. 280 plus 240 plus 300 gives me a total of 820. And there are no units on here, so we're just going to say units squared. The surface area is going to be all 3 of the lateral faces. So I'm just going to write down lateral area plus the 2 bases. Okay, our lateral area, remember, was 820 from up above. Now our 2 bases were both triangles, and each one was 91. So if we add 820 plus 91 plus 91, our total surface area is 1,002 units squared. Now, at this point, I do like to start talking about formulas. We can use formulas to find lateral area and surface area, but each figure is different, and therefore sometimes there's different formulas, and it's a lot to memorize. So let's go through and look at what those formulas would be, and then we can, as we look at these next few problems, we can kind of look at both methods, using the formula versus finding it piece by piece. Okay, what I want you to notice about the lateral area specifically, so the 3 rectangles, if you look back at how we found the area of all 3 of these rectangles, you'll notice that they all had one thing in common. They all had this 20 in common. Okay, and that 20 was multiplied by 3 different lengths. First, the 20 was multiplied by the 14, then it was multiplied by the 12, and then that 20 was multiplied by the 15. So really, if you look at that as distributive property, you had to do 20 times 14, 20 times 12, and 20 times 15. And that would have given you your 3 areas. Okay, so think of this as your lateral area. Now, if we go back and look at a formula, what was that 20 representing and what were that 14, 12, and 15 representing? The 14, 12, and 15, when you add this 14, 12, and 15, what you're actually finding here is the perimeter of the base. The base, remember, was a triangle, and the triangle had sides of 12, 14, and 15. So when we're finding our lateral area, we start with the perimeter of the base. Then this 20 is actually representing the height of the prism. Now, in a lot of cases, it doesn't appear to be the height. So I do like to emphasize that when we talk about the height of a prism, the height of a prism is the distance between the bases. You have to visualize this prism. I'm going to redraw it. You have to visualize this triangular prism with the triangle base at the bottom and the second triangle base at the top, and the distance or the segment connecting those, that's going to be our height. So when we're finding our lateral area, we could use this formula to be able to find our lateral area. And in fact, I'm going to go back and write that up here with our definition. To find our lateral area, we can take the height of the prism and multiply it by the perimeter of the base. Now, how did we find the surface area? The total surface area. To find the total surface area, we just took that lateral area from above, and then we added on the area of the two bases. So to find our total surface area, we could use the formula lateral area plus the two bases. Now, as you're using these formulas, there are definitely a few things you're going to have to pay attention to. What shape is the base? Okay. And once you determine what shape the base is, that's going to tell you what formula to use for the area of the base. Okay, for the lateral faces, since the lateral faces will always be some form of a parallelogram, you will always be using the formula of base times height for those lateral faces. So as we've seen a couple of examples now, let's look at another example. And this time we are going to try this using both methods so that we can kind of compare and decide what method you like best. So method 1, method 2. And I'm always going to start with method 1. Method 1 is where we're going to break it apart, look at the individual surfaces, find the individual areas, and then add them together. Okay, starting with what is the name of the prism? Again, look for those parallel and congruent bases. In this case, my bases, my two parallel and congruent bases are these triangles. So once again, this is a triangular prism. So now we'll go back from method 1. We'll find the area of each one of these surfaces. There are actually 2 triangles, and then there are going to be 3 rectangles, and we're going to find the area of each one. Now the triangles, you'll notice, are actually right triangles. So to find the area of these triangles, 1/2 base times height, and because they're right triangle, the height and the base are actually identified in the triangle itself. So the area of this one triangle is 1/2 8 times 15. And if we do 1/2 8 times 15, 4 times 15 is 60. So that means each one of these triangles is 60. Remember, the bases are always congruent. Now, as for the rectangles, there are 3 of them. They're not always the same. So we're going to look at each one individually. First, I'll look at this one on the bottom. And this rectangle on the bottom, we're going to have to multiply 15 times 18. So 15 times 18 gives me a rectangle of 270. Then I'm going to look at this rectangle out in the front here. Okay, this one. This one is 18, and this side is 17. So now we're going to do 17 times 18. And this rectangle is 306. And then the last one, I'm going to look at this rectangle, this little one in the back here. This one looks like a height of 8. And again, this base is going to be the same as that 18. So this one is going to be 8 times 18. And 8 times 18 is 144. So now, for our two different answers, we need lateral area and surface area. For our lateral area, we're just adding together the three lateral surfaces, 270 plus 306 plus 144, 270 plus 306 plus 144 is 720 centimeters squared. For our surface area, we're going to start with that lateral area of 720, and this time we're going to add both bases. So 720 plus 60 is 840 centimeters squared. Okay, so that's method one. What I like about method one is short of knowing your basic formulas, you don't have to memorize any new and additional formulas, you just have to identify the shapes. Now method two is use those two formulas that we came up with before. To find the lateral area, we're going to multiply the height of the prism times the perimeter of the base. Okay, so we'll start with identifying the base. The base, remember, we said was this right triangle. And the perimeter of that base would be adding together the 8, the 15, and then this third side was that 17. So we'll start with adding the perimeter, 8 plus 15 plus 17. Now the height of the prism, remember, is the distance between the bases. So the height of my prism is 18. And if I add 8 plus 15 plus 17, that's going to give me 40. And when I multiply that by 18, that's going to again give me that 720 centimeters squared. Same as down here. For my surface area, I'm going to start with that lateral area, plus I'm going to add on the two bases. So I'll start with my 720. Now each of my bases was this triangle. So I would still have to have done this part. I still have to come up with the area of that base. And since there were two of them and each of them was 60, that's going to leave me with this same 840 centimeters squared. So both of these first two examples were triangular prisms, where the base was a triangle and the lateral surfaces were all rectangles or parallelograms. As we look at this example, okay, notice the bases. Now, I am telling you here that the bases are regular polygons. And when we count up the surfaces, we can see that there are 1, 2, 3, 4, 5, 6 sides, which means that these bases are hexagons, making this a hexagonal prism. Now, again, we can solve this using two different methods. So method one is that I'm going to find all of the different surfaces, and then method two, I'm going to come back and try to use my formula. When you think about method one, think about your surfaces. There are two bases, and each base is a hexagon. So the first thing we're going to have to do is know how to find the area of these hexagons, and there's two of them. Then there are parallelograms. In this case, our parallelograms are rectangles. And since that hexagon has 6 sides, there's actually going to be 6 rectangles that are connecting those two bases together. So we're going to be looking for 8 different surfaces on this one. Now let's talk a little bit about, I'm actually going to slide this up and give us a little bit more room here. Or actually, I'll slide this down. Okay, let's talk about these hexagons. How do we find the area of a regular polygon? That was that formula, 1/2 the apothem times the perimeter. Okay, so let's start with what is the perimeter of this regular hexagon. Since the hexagon has 6 sides, and the side of each one is 4, my perimeter is going to be 6 times 4. The next thing I need is my apothem. And that one's the one that takes a little bit more work. For the apothem, we had to draw in our center and draw in our first triangle. Then remember that this central angle, since it's part of a complete circle, and there are going to be 6 of these triangles, we had to do 360 divided by 6 for a central angle of 60 degrees. Now the apothem was drawn directly was essentially the altitude of that triangle. So it was perpendicular to the side. So then we looked at one of these smaller triangles right here, this smaller right triangle, and I'm going to redraw mine out to the side here. And our job is to find this apothem. What we know is that this distance was 2, so I'm going to relabel this 2. Since this angle was 60 degrees, but it got cut in half, we know that this angle is 30 degrees, and that means that this angle down here was 60 degrees. Okay, in your 30, 60, 90 triangle, you know that the side across from the 30 is your A value, and we know that the side across from the 60 is A root 3. So that means that my apothem was 2 root 3. Now, once I do all of that work, now I can come back here and actually find the area of my one regular hexagon. So when I multiply all this together, and I'm going to leave it for the time being in terms of root 3. So that means all I'm really doing is multiplying 1/2 times 2 times 6 times 4. And that's going to give me 24 root 3. That's one base. Now there are 2 identical congruent bases, so now we've got our 2 hexagons. As for our 6 rectangles, because if you look at just one of these rectangles, okay, I'm going to look at this one at the top here. This rectangle is 17 units long. And if we look at how wide it is, it's going to be that 4 centimeters. Remember that it's a regular polygon, so all of those sides are the same. So that means that this rectangle is going to be 4 times 17. Now, because all of these sides are the same, all of these rectangles are actually going to be 4 times 17. So here's a case where actually all of the lateral faces are congruent. If we do 4 times 17, that's going to give us an area of 68 for one rectangle, and then there are 6 of those rectangles. So 6 times 68, that's going to give us a total of 408. Okay, so now, what have we found? Remember that the lateral area is only going to be the 6 rectangles. Well, we've already found that one. The lateral area is going to be the 6 times 68, which was a total of 408. And looks like this one did have units of centimeters squared. The surface area is going to be that lateral area plus the 2 bases. Now the bases were 24 root 3 and another 24 root 3. And when I add these 2 together, that's going to give me 48 root 3. So my surface area is 408 plus 48 root 3. And again, my units are centimeters squared. If I was to ask you for an exact answer, this would be the exact answer. You would leave it with that addition, and you would leave it with that square root 3. If I ask you for a decimal answer or a rounded answer, then you could put this in your calculator. 408 plus 48 root 3. And as a decimal, that is approximately 491.14 when we round it. So again, you could give answers in different ways. Just pay attention to what the directions are asking. Okay? Now, method 1 required us to separate it into 2 hexagons and 6 rectangles. Method 2 is saying, let's use our formulas. For the lateral area, we know that we're going to do the height of the prism times the perimeter of the base. Okay, well, the perimeter of the base, remember, the base was a hexagon. That hexagon has 6 sides. Each side was 4 units. So for the perimeter of the base, it's just 6 times 4. The height of the prism is going to be that distance between the bases. And remember that distance between the bases was that 17. So for the lateral area, I'm going to do 17 times 6 times 4. And there is that 408. Now again, notice that it does match the answer that we got down here when we did it in the other method. Okay, units, centimeters squared. For the total surface area, we're going to take the lateral area plus the two bases. The lateral area was 408, and the two bases were 24 root 3 each. Here's the thing, class. No matter which method you use, you're going to have to be able to do this. You need to know the area of the base, whether you're doing it the longer way or the shorter way. You're still going to have to do this part of it. Okay, and once we come down here, 408 plus 2 times 24 is 48 root 3. And just like before, we can leave it in terms of the square root. This would be the exact answer. Or we could put it in that calculator and get the decimal answer as well. Okay. Okay, example 4, last example. This one's going to be a quicker one. Name the prism. Okay, so again, look for the identical and congruent surfaces. Sometimes it's a little bit harder to see on one of these prisms because all the surfaces appear to be rectangles or squares, parallelograms, something that falls into that parallelogram category. So what you want to look for are the parallel and congruent ones. What I notice right away here is that I have this surface, and that in this, let's call it a rectangle, we can see that the base and height are both the same. So in a rectangle, if the sides are the same, we would actually call this a square, and the surface that is parallel to it is going to also be congruent. So we could call this a square prism. Now, technically, since a square is a type of rectangle, you could also call it a rectangular prism. And really, if you think about the definition, all we said was that the bases had to be parallel and congruent. Well, technically, this base down at the bottom, this rectangle, would be congruent to this rectangle that is parallel to it up at the top. So when we ask for what are the bases, it's a little bit harder to determine that because we do have parallel and congruent rectangles at the top. We have parallel and congruent squares on the sides. So we could call a number of things the bases. Generally, if there is one surface that is different than the rest of them, so in this case, we're talking about these squares, we're generally going to refer to these as the bases when we are trying to name it, as well as when we are finding the lateral and the surface areas. Okay, so if we look at method 1, which is just breaking it up into pieces, in method 1, we would notice that there are actually two squares, and the squares are going to be 7 by 7, so there's actually two surfaces that are 49. There's also going to be 4 rectangles. These are going to be our lateral surfaces. And because the bases are squares, once again, because these bases all have the same sides, then each one of these rectangles is going to be the same. So to find the area of, let's say, one of these rectangles, I would have to multiply 15 by 7. 15 by 7 is 105. And since there are 4 of those rectangles, 4 times 105 is 420. Okay, so for my lateral area is just going to be those 4 rectangles, so 420 centimeters squared. My surface area will be that lateral area plus the 2 bases. So if I add that 49, that's going to give me 518 centimeters squared. And again, this could work just as well with our formulas. In method 2, the lateral area is the height of the prism times the perimeter of the base. The perimeter of the base is a square, so there are 4 sides, and each side is 7 units long. The height is the distance between the bases. In this case, that's 15. So 4 times 7 is 28, and 15 times 28 is that 420 again. And you'll notice that by the time we get to surface area, no matter which method we're using, we're essentially doing exactly the same thing. By the time we get to surface area, we know that we have to take that lateral area plus the two bases, and we're going to get that same 518 centimeters squared. So your task is to work on finding the surface area and lateral area. Pay attention to which one it's asking, or both, of a variety of different prisms. Make sure you really pay attention to how to find the area of the base. So for example, if your prism does have a base that is a regular polygon, a regular hexagon, or a regular pentagon, you will have to go back to this formula from our last unit to be able to find that area. And always remember to make sure that you are labeling your answers. If the units are not given, like in our first example, feel free to just use units squared